Next term is a source of sewage. Variation in that first one, variation of sewage flow, then flow quantity estimation. So first one, wastewater flow. The total wastewater flow can be divided into dry weather flow, and second term is a wet weather flow. So what is by dry weather flow? It is a flow of wastewater during non-rainy season. It is mainly due to domestic sewage and industrial wastewater. Second term, wet weather flow. It is the flow of wastewater include storm water during rainy season. So factor affecting a dry weather flow. So first factor is rate of water supply. Second factor, population growth. Third, type of area. And last one, infiltration of groundwater. So depend on infiltration, depth of sewer below ground level, then size of sewer, then length of sewer, next nature and type of soil, then types of joint, and last one is a sewer materials. Infiltration estimation, the following are the infiltration estimation. Area basin. So rate of infiltration is expressed as a liter per hectare of area per day. Normally, area of basin is 5,000 liter per hectare per day. Length of basin. The rate of infiltration is expressed as a liter per unit length per day. Normally, 10,000 liter per kilometer per day. Diameter of length basin. Most rational method infiltration rate is expressed in liter per centimeter per kilometer per day. So variation in rate of sewage. The rate of sewage flow never remain constant. So following are the design concern, maximum and minimum flow, no deposition. These are the formula of maximum and average rate of flow. So first formula, Q max is equal to 5Q average divided by P raised to 0.2. So in the next formula, Herman's formula, Q max in bracket 1 plus 14 plus 4 plus P raised to 0.5 bracket complete Q average. So what is by Q max? A maximum rate of flow, Q average, average rate of flow, and P means population in 1000. So next factor is a peaking factors. The effect of daily variation is maximum on domestic and lateral sewers as they receive directly from source. The effect reduces gradually as the flow reaches to branch and mains. Various sewers are designed not for average annual flow, but for a flow rate which is higher than average flow rate by peaking factor. The peaking factor is equal to, in bracket, peak flow divided by average flow. It is a table of peaking factor for different types of sewers. So first one is a domestic sewers. The factor multiply average rate of annual flow 6. Lateral sewer 4 to 6. Branch sewer 3. Main sewer 2.5. And outflow sewer is a 2. These are a peaking factor depending upon population and peak factor. Up to population is 20,000, the peak factor should be considered 3.5. The population in between 20,000 to 50,000, the peak factor should be 2.5. And the population between 50,000 to 750,000, the peak flow should be considered 2.25. And above 750,000, the peak flow should be considered 2. So next time is a minimum flows. It is a occurring during the night hours. Effect of minimum flow is maximum on lateral sewers as they get house drainage directly. While such effect is very small on trunks, sewer are fluctuation in flow gates dams. Depend on stormwater and flow rate. The following are the area or following are the point should be considered. First, catchment area. Second, ground slope. Third, permeability of ground. Then next, extent of impervious area such as building road. Extent of vegetation growth, rainfall intensity, rainfall duration, then condition of ground to rainfall, and last one is the climate condition such as wind, temperature, humidity, etc. During design of sewers for estimation, the storm water flow following two methods are commonly used. First one is the rational method and second one is the empirical method. So first method is a rational method. In this method, rational formula is a mostly commonly used in estimation of storm water flow. This is taken into account for following three factors. First, catchment area, then impermeability of soil or catchment area and rainfall intensity. The natural formula is nothing but a Q is equal to K into A into I into R suffix small I. So Q is nothing but a run off or storm water flow. K constant that permits the expression of A, I, and R in conventional unit. Let us see what is by Q. Q is a runoff in cumex, A catchment area in hectare, AI impervious area, nothing but A into I, and Ri is equal to intensity of rainfall in mm per hour. So second formula is empirical method. So rational method is suitable when the area drainage of water to sewer is small, say smaller than 400 hectare. Hence, the large area empirical method is more suitable. Or empirical formula are applicable to some specific condition and not to everyone. So following are the variable are considered in this formula. First, catchment area in hectare, then rate of intensity of rainfall in per hour. Third one, relative impervious, and D, slope of ground in meter per 1,000 meter length. So these are the formula of storm water flow and runoff. These are nothing but a small formulas for calculating of storm water and flows. So next term is a hydraulic design of sewer. In the first introduction, as the sewage is mostly contain 0.1 to 0.2% of solid matter and rest of is a liquid. The design of sewer is similar to design of water mains. Still, there are two different in the design of sewer than water mains. So first, presence of solid matters, and second, pressure. The following are the hydraulic formula. First, Chase's formula, then Kutter formula, then mapping formula, then Krimp formula, and last one is a Hazan's formula. So first one is a Chase's formula. The formula is a V is equal to C under root of R into S. So what is my V? V is a velocity of flow in meter per second. S is equal to hydraulic gradient and slope of sewers. R is equal to hydraulic main radius. A is equal to cross-sectional area in meter square. P is equal to weighted perimeter, and C is equal to Chase's constant. Second point, Chase's constant means C is depend on roughness of inner surface, hydraulic means radius, and size and shape of sewer. C can be find out from Kutter or Benzine's formula. Knowing the velocity of flow V from Chase's equation, the channel section is designed by general formula. Q is equal to A into B, where Q is discharge in meter cube per second. So next formula is a Cutter's formula. C is equal to 23 plus 0.00155 divided by S plus 1 raised to n. The whole term is divided by 1 plus 23 plus 0.00155 divided by S bracket complete n divided by under root of r, where n is equal to a coefficient depend on nature of inner surface of sewer. S is equal to hydraulic gradient and slope of sewer, and R is equal to hydraulic mean radius. The value of Coulter and Manning coefficient in variable condition. First, conduct materials. In that first material, salt granite stoneware, the condition of interior surface 0.012 and 0.014. Cement concrete, condition of interior surface 0.013 and in fair value 0.015. Cast iron 0.012 and 0.013. Bricks 0.013 to 0.015. Asbestos cement 0.011 to 0.012. Plastic smooth 0.011 to 0.011. Then next formula, benzene's formula. This is the important formula. C is equal to 157.6 divided by 1.81 plus K divided by under root of R, where K is equal to benzene's constant taken from table. So this is a table for value of K. In that first line, nature of inside of sewer, and the second table, the value of K. So in that, in first very smooth surface, so value of K is taken as a 0.109. Second, smooth brick or concrete surface, the value of K is a 0.29. Rough brick or concrete surface, the value of K is a 0.833. Smooth rubble masonry surface, the value of K is a 1.54. Good earthen channel, the value of K is a 0.50. And rough earthen channel, the value of K is a 3.17. The next formula is a Manning's formula. C is equal to 1 divided by N into R raised to 2 divided by 3 into S raised to 1 divided by 2, where V, N, R, S have some meaning as a before N from Cutter's formula. So the next formula is the next formula is a cream formula. So first one, V is equal to 83.47 R raised to 2 by 3 into S raised to 1 by 2. Simply is equal to R raised to 2 by 3 into S raised to 1 by 2 divided by N, which given N is equal to 1 divided by 83.42 is equal to 0.012. For circular diameter of pipe, these are the following the formula. So this is the formula. Q is equal to 26.02 D raised to 8 divided by 3 into S raised to 1 divided by 2. So next formula, Hazen's formula. B is equal to 0.85 C into R raised to 0.63 into S raised to 0.54. C is a constantly mostly used for flow of under pressure. So this is the table of Hazen's coefficient. So in first table, types of material, and second table, the constant coefficient. So first, steel pipe, the value of C is a 95. Second, old cast iron pipe, or brick sewer under good condition, the value of C taken as 100. Third, stone weir pipes under good condition, the value of C is 110. Cement line pipe, the value of C is 110. New riveted steel pipe, the value of C is 110. Wood stove pipe, the value of C is 120. New cast iron pipe, the value of C is 130. Pipe with very smooth surface, the value of C is 140. And asbestos cement pipe, the value of C is taken as 140. So next term is a minimum velocity. So this is also called as a self-cleaning velocity. It may be defined as that velocity at which the solid particle will remain suspension. So following is the expression, shield expression of self cleaning velocity. Vc is equal to 8 under root of 8 beta divided by f in bracket gs minus 1 bracket complete into small g into ds, where beta is equal to 0.04 for initial score of clean grit or 0.8 for removal of sticky grit. A grit nothing but a small types of silt or clay or stone. So next point is the maximum velocity. This is also called as a non-scoring velocity. It is a maximum velocity of flow in sewer such there should be not any wearing of surface. So following our table, we should denoted by first table material of sewer and the second table is non-scoring velocity. Then hydraulic element of circular sewer. A circular sewer are mostly preferred over other section because first one, they are very easily manufactured. Second, it gives maximum area for given perimeter, thus gives greatest HMD when running full or half. Third, most efficient of section under various flow of condition. Next, most economical section since utilize minimum quantity of materials. Fifth, it is offer less possibility of solid accumulation due to smooth curvature of all round. A circular section if running full. The formula area is equal to pi by 4 into d square. Weighted perimeter P is equal to pi d, and HMT is nothing but the hydraulic mean depth R is equal to A divided by P is equal to D by 4. In circular section, the following are the formula for depth. D is equal to, small d is equal to capital D divided by 2 in bracket 1 minus cos of theta by 2 bracket complete. Area is equal to small a is equal to pi d square divided by 4 in bracket theta divided by 360 minus sine theta divided by 2 pi. Weighted perimeter, the formula of weighted perimeter is equal to P is equal to pi d divided by theta divided by 360. Then HMD, nothing but the hydraulic mean depth. Small r is equal to d by 4 in bracket 1 minus 360 sine theta divided by 2 pi theta. Then next, velocity of flow. The following are the formula. So write down this formula. The small v is equal to 1 raised to n into r raised to 2 by 3 into s raised to 1 by 2. Discharge q is equal to area into velocity. So this is the problem. Okay. We will continue in